Imagine if the story of human innovation, the slow and steady march from primitive tools to complex machines, was not as straightforward as we have always believed. Imagine if woven into the very fabric of our past, there exist echoes of a different kind of knowledge, a craftsmanship so precise, so monumental, that it defies every assumption we hold about early civilizations. This is the central mystery we confront, ancient sites and artifacts scattered across our planet that stand as silent testaments to technological capabilities that, by all conventional accounts, should not have existed. For generations, we have charted human history as a linear progression. From the first crude stone implements through the mastery of agriculture, the invention of the wheel, the forging of metals, and on to the marvels of our modern world. Each step, a logical, incremental advance, building upon the last. This narrative paints a clear picture of how humanity evolved its understanding of engineering, physics, and construction. But what if this blueprint, so carefully drawn, contains profound gaps? What if certain accomplishments from the deep past leapfrog centuries, even millennia, of supposed development, leaving us with a perplexing paradox? This challenge to our linear understanding of innovation is not merely academic. It manifests in solid stone, in impossible cuts, and in structures of bewildering complexity. It forces us to ask whether we have fundamentally misunderstood the true capabilities of our ancestors, or if there is another explanation entirely for these profound anomalies. These are not isolated curiosities. They are a persistent whisper from antiquity, suggesting a level of ancient technology that remains largely inexplicable even today. The very existence of such sites compels us to reconsider the established timeline of human ingenuity in question. If the past holds secrets far more advanced, then our textbooks allow one of the most striking examples, a true architectural enigma that consistently confounds engineers and archaeologists alike, lies high in the Bolivian Andes. This is Puma Punku, part of the larger Tiwanaku site, standing at an elevation of nearly 13,000 feet. It is a ruin, yes, but a ruin like no other. Here, massive blocks of stone, some weighing over 100 tons, are carved with a precision that seems to transcend the capabilities of any known ancient culture. These are not rough-hewn boulders. They are finely shaped, interlocking components, many exhibiting intricate designs, internal angles, and perfectly straight cuts that challenge belief. The most famous of these are the H blocks. These are not just decorative pieces. They are structural components meticulously crafted from hard andesite and diorite. Imagine cutting stone harder than modern concrete with tools of bronze or even softer materials. Puma Punku's H blocks are essentially modular units, fashioned with incredibly tight tolerances. They have perfectly flat surfaces, laser-straight edges, and internal 90-degree angles that would require sophisticated instruments to achieve even with today's technology. Some of the cuts are so fine, so smooth, that it appears as if the stone was not carved but molded. The precision is such that a razor blade cannot be slipped between the joints of some remaining fitted blocks. This suggests an understanding of geometry and stoneworking far beyond what the Tiwanakan people are traditionally credited with. Consider the scale of the challenge. The stones at Puma Punku are primarily red sandstone and andesite. The sandstone blocks, though enormous, were sourced from a quarry about 10 kilometers away. The andesite, however, presents an even greater mystery. This incredibly hard volcanic rock was transported from a quarry roughly 90 kilometers away, across treacherous terrain, including bodies of water. How were these multi-ton blocks moved, let alone hoisted and positioned at such an altitude, without the aid of wheels, draft animals, or any known advanced machinery? The conventional explanations involve thousands of laborers, ropes and ramps, but even these struggle to account for the sheer scale and difficulty, especially when considering the extreme precision of the finished products. The logistical feat alone is staggering, but it pales in comparison to the question of how they were carved. Mainstream archaeology often attributes these achievements to painstaking manual labor, using primitive tools and an immense investment of time and human effort. Yet when one examines the evidence closely, this explanation begins to fray. The precise, almost machine-like cuts, the perfectly uniform channels, the consistent angles across countless blocks. These are not typically the hallmarks of chisels and mallets. They suggest a level of control and accuracy that would necessitate advanced understanding of not only stone cutting but also measurement, calibration, and perhaps even some form of mechanical assistance. It's as if the builders possessed a knowledge of industrial-scale engineering in an era when such concepts were supposedly centuries away. This leads us directly to the paradox of the past. We are presented with cultures often described as primitive or Neolithic, achieving monumental and intricate results that seem utterly incongruous with their supposed technological toolkit. How could a civilization without a written language, without the wheel, without iron tools, execute such sophisticated stonework? Pumapunku isn't an isolated anomaly. It's a glaring beacon in a constellation of similar architectural puzzles across the globe. From the megalithic structures of ancient Egypt to the precision of Inca stonework, the same questions echo. How did they do it? The gap between the presumed technology and the undeniable results is so vast that it compels us to look beyond simplistic answers. It's a riddle carved in stone, a silent challenge to the very foundation of our understanding of history. The materials themselves add another layer to this paradox. Andesite and diorite are exceptionally hard stones, far more difficult to work than limestone or granite. To shape them with such detailed accuracy, modern stone masons would employ diamond-tipped saws and drills. The idea that this could be achieved through hours of grinding with softer stones and sand, while physically possible in some instances, struggles to explain the sheer volume of material worked, the uniformity of the cuts, and the intricate internal angles seen at Pumapunku. It is as if the builders possessed an overlooked command over material science, an innate understanding of how to manipulate rock on a grand scale, perhaps through methods we have yet to rediscover, and so we find ourselves standing at the edge of a profound historical precipice. The evidence at sites like Pumapunku suggests that ancient peoples were capable of feats that we, with all our modern advancements, would struggle to replicate without specialized heavy machinery and advanced engineering principles. It's not just about moving big stones, it's about shaping them with industrial-level precision using tools that, by all accounts, should not have existed. This disjunction creates a compelling narrative. Either our understanding of ancient technology is woefully incomplete, or there was an extraordinary, perhaps even forgotten, intervention in humanity's early development. This inherent contradiction sparks within us a fundamental human drive, the urge to unravel what lies beyond conventional explanation. We are drawn to mysteries, particularly those that challenge our established frameworks. When confronted with evidence that does not fit, our minds instinctively seek deeper truths, alternative narratives. The Sphinx's eroded base, the precise alignments of ancient observatories, the metallurgical wonders of lost empires. These are not just archaeological curiosities. They are invitations to explore the limits of our knowledge, to push beyond accepted dogma, and to consider possibilities that might at first seem outlandish. The whispers of impossible craftsmanship from Pumapunku and countless other sites resonate with this deeply ingrained human need to understand, to know, and to reconcile the seemingly irreconcilable. It is the quest to understand these ancient technological marvels that forms the heart of our journey through the forgotten echoes of the past now leads us from the whispers of impossible craftsmanship to the tangible, unyielding evidence etched in stone itself. If the H-blocks of Pumapunku spoke of a forgotten precision, then other ancient megastructures cry out with a scale and an intricacy that challenge everything we believe about early engineering. For across continents, civilizations we deem primitive moved mountains of rock, not with brute force and simple tools, but with a mastery that seems almost otherworldly. Consider Baalbek in modern-day Lebanon, a site of monumental Roman temples built upon a foundation that predates them by millennia. Here, beneath the grandeur of classical architecture, lies the true enigma, the platform of the Jupiter Temple. Within its retaining wall rests the trilithon, a trio of carved limestone blocks, each weighing an estimated 800 to 1,000 tons. To put that in perspective, a modern locomotive weighs around 150 tons. These stones are not merely large, they are colossal, some of the heaviest work stones ever moved by humanity. They are placed with such precision, almost seamlessly, that a knife blade can barely pass between them. The quarry itself, a mile away, contains an even larger stone, the Stone of the Pregnant Woman, weighing well over 1,200 tons, partially cut but never moved. How were these giants quarried from the bedrock with the tools available to ancient man? How were they transported over a mile of uneven terrain? And perhaps most baffling of all, how were they lifted and positioned to form a perfectly level platform, many feet above the ground? With a fitting so tight it defies modern construction methods without heavy machinery. The sheer physics involved in such an undertaking remains an unsolved riddle, a testament to a strength and a technique that falls utterly outside our historical understanding. It suggests a command over material and mass that we struggle to replicate even with our most powerful cranes and lasers. The mystery deepens when we turn to the heart of ancient Egypt. To the Great Pyramid of Giza, we understand the ingenuity of its internal structure, the vast number of blocks used and the astronomical alignments. But the outer casing stones of the pyramid present a different kind of puzzle, one of precision taken to an extreme that seems almost impossible. Originally, the Great Pyramid was encased in 115,000 highly polished Tura limestone blocks, weighing up to 15 tons each. These stones were cut with such astonishing accuracy and fitted together with such minimal gaps, often less than half a millimeter, that it was said a razor blade could not be inserted between them. This was achieved over an area of more than 5.5 hectares across a structure that reaches over 140 meters high, covering a total surface area of approximately 90,000 square meters. The precision is not just in the flatness of the stone faces, but in the exact angles required for the pyramid's slope, maintained flawlessly over its immense height. How did the ancient Egyptians achieve this level of accuracy without modern surveying instruments, without machine-driven saws to ensure perfect flatness, and without the means to precisely lift and adjust such heavy blocks? The sheer scale of this task, combined with the microscopic tolerances achieved, forces us to question the conventional narrative of copper tools and simple ramps. It suggests a command of geometry, a mastery of stone cutting, and a logistical capacity far beyond what we attribute to a civilization supposedly limited by primitive technology. What kind of tools could achieve such mirror-like finishes and such perfect angles on limestone, a material hard enough to resist simple abrasion, but soft enough to be damaged by imprecise handling? Then there are the inner sanctums of Egypt, the sites that reveal an even more unsettling level of precision, one that borders on the truly inexplicable. Deep within the Serapeum at Saqqara, or scattered across other ancient sites like Abydos and the Giza Plateau, lie massive granite and basalt sarcophagi and boxes. These objects, often weighing 70 to 100 tons, are carved from some of the hardest stones on Earth. Their exterior surfaces are polished to an incredible luster, but it is their interiors that defy explanation. The inside corners are perfectly square, sharp as if cut by a modern milling machine, rather than rounded as they would be with ancient hand tools. The interior walls are perfectly flat and parallel to each other, with tolerances measured in fractions of a millimeter, far exceeding anything achievable by chisels and mallets. Some of these boxes feature lids weighing 20-30 tons, sealed with such exactitude that they create a vacuum seal when lifted. The sheer hardness of the material, combined with this impossible precision, indicates an advanced cutting technology we have yet to discover. What kind of drills could create perfectly smooth, deep holes in granite with no visible start or endpoint for the drill bit? What kind of saw could cut through tons of solid basalt, leaving behind tool marks that resemble modern industrial cutting tools, yet without any corresponding archaeological evidence for such machines? The meticulous work seen on these granite masterpieces points not just to skill, but to a different order of technology entirely. A technology capable of manipulating stone with a degree of accuracy that still challenges our own industrial capabilities. It speaks of a lost knowledge in metallurgy, in power generation, and in the very physics of working with intractable materials. This impossible precision and colossal scale bring us to perhaps the most fundamental challenge presented by these ancient megastructures, the logistical nightmare of transporting and placing such massive blocks without known advanced machinery. From Stonehenge's bluestones, brought over hundreds of miles, to the megaliths of Sacsayhuaman in Peru, where multi-ton stones are perfectly fitted into complex interlocking walls high in the Andes, the same question echoes. How? We propose theories involving rollers, sledges, and vast numbers of human laborers. Yet, these explanations often fail to account for the sheer physical constraints. How do you move a 1,000-ton block on wooden rollers without them crushing under the immense weight? How do you maintain control of such a mass on an incline without it careening downhill? And once at the site, how do you lift it dozens of feet into the air and position it with millimeter accuracy using only ropes and ramps? The archaeological record offers scant evidence of the required scale of such operations. There are no vast, ancient road networks specifically designed for these ultra-heavy transports, no remnants of colossal cranes or complex leverage systems that could manage these weights. The simple methods proposed often fall apart under rigorous engineering analysis, either requiring impossible numbers of people, an unrealistic amount of time, or violating fundamental laws of physics as we understand them. The prevailing narrative leaves us with a significant gap, a chasm between the capabilities we attribute to these cultures and the physical evidence they left behind. It suggests that perhaps our understanding of their technology is fundamentally incomplete, missing a critical component that allowed them to achieve what we still consider Herculean tasks. And the mysteries are not limited to the careful shaping and precise placement of cold stone. Across the ancient landscapes of Scotland, particularly in its northern reaches, lies another form of stone engineering that hints at an entirely different, perhaps even more startling, lost technology, the enigmatic vitrified forts. These are hilltop fortifications where the stone walls, instead of being simply stacked or mortared, have been subjected to such intense heat that the rock has melted and fused together, forming a glassy slag-like material that binds the structure into a single, incredibly strong mass. Achieving vitrification requires temperatures of 1,000 to 1,200 degrees Celsius, sustained for prolonged periods, akin to modern industrial furnaces. This is not simply a matter of setting a few bonfires. It requires a controlled, high-temperature environment that melts quartz-rich stones. Yet, these forts date back to the Iron Age, a period where such pyrotechnical mastery is entirely unexpected. How did Iron Age peoples, supposedly limited to basic kilns and hearths, generate and control such extreme and sustained heat over such vast areas? There is no evidence of the massive quantities of fuel required for such an operation, nor the advanced refractory materials needed to contain and direct the heat. Were these structures deliberately crafted in this way for defensive purposes, making them virtually impregnable? Or was the vitrification an unintended consequence of some other process, perhaps ritualistic or industrial, that we do not comprehend? The very existence of these vitrified forts shatters our assumptions about the metallurgical and pyrotechnological capabilities of these ancient cultures. It suggests a profound understanding of heat, material science, and possibly even chemistry that appears to be entirely out of place for their documented era. It is as if they possessed the secrets of a foundry on a monumental scale long before such knowledge should have existed. These are not isolated anomalies. They are recurring patterns across the ancient world. From the perfectly shaped multi-ton stones of the Osirion at Abydos, cut from granite with incredible flatness, to the unknown methods behind the massive, interlocking walls of ancient Peru, the evidence points to a technological sophistication in stonework that transcends the known historical record. The sheer weight of these objects, the precision with which they are cut, the baffling logistical challenges of their placement, and the unexplained high-temperature methods used to transform them all converge on a single, inescapable conclusion. Our ancestors possessed a mastery over stone and engineering that far exceeds the tools and knowledge we currently attribute to them. What force was at play? What lost techniques allowed them to manipulate materials in ways that still elude us today? These questions are not mere academic curiosities. They are direct challenges to our linear understanding of human progress, suggesting that the past holds secrets of a forgotten ingenuity waiting to be rediscovered. And as we peel back these layers of stone, the possibility emerges that the marvels of ancient engineering were not just about moving rocks, but about harnessing powers and understanding materials in ways that echo far beyond the simple. This leads us to the next profound question. If stone itself reveals such an advanced understanding, what other materials and mechanisms equally inexplicable lie hidden in the ancient record? Our journey through the forgotten echoes of the past now leads us from the whispers of impossible craftsmanship to the tangible, unyielding evidence etched in stone itself. If the H-blocks of Pumapunku spoke of a forgotten precision, then other ancient megastructures cry out with a scale and an intricacy that challenge everything we believe about early engineering. For across continents, civilizations we deem primitive moved mountains of rock, not with brute force and simple tools, but with a mastery that seems almost otherworldly. Consider Baalbek in modern-day Lebanon, a site of monumental Roman temples built upon a foundation that predates them by millennia. Within its retaining wall rests the trilithon, a trio of carved limestone blocks, each weighing an estimated 800 to 1,000 tons. To put that in perspective, a modern locomotive weighs around 150 tons. These stones are not merely large, they are colossal, some of the heaviest work stones ever moved by humanity. They are placed with such precision, almost seamlessly, that a knife blade can barely pass between them. The quarry itself, a mile away, contains an even larger stone, the stone of the pregnant woman, weighing well over 1,200 tons, partially cut but never moved. How were these giants quarried from the bedrock with the tools available to ancient man? How were they transported over a mile of uneven terrain? And perhaps most baffling of all, how were they lifted and positioned to form a perfectly level platform, many feet above the ground, with a fitting so tight it defies modern construction methods without heavy machinery? The sheer physics involved in such an undertaking remains an unsolved riddle, a testament to a strength and a technique that falls utterly outside our historical understanding. It suggests a command over material and mass that we struggle to replicate, even with our most powerful cranes and lasers. The mystery deepens when we turn to the heart of ancient Egypt, to the Great Pyramid of Giza. We understand the ingenuity of its internal structure, the vast number of blocks used, and the astronomical alignments. But the outer casing stones of the pyramid present a different kind of puzzle, one of precision taken to an extreme that seems almost impossible. Originally, the Great Pyramid was encased in 115,000 highly polished Tura limestone blocks weighing up to 15 tons each. These stones were cut with such astonishing accuracy and fitted together with such minimal gaps, often less than half a millimeter, that it was said a razor blade could not be inserted between them. This was achieved over an area of more than 5.5 hectares across a structure that reaches over 140 meters high covering a total surface area of approximately 90,000 square meters. The precision is not just in the flatness of the stone faces, but in the exact angles required for the pyramid's slope, maintained flawlessly over its immense height. How did the ancient Egyptians achieve this level of accuracy without modern surveying instruments, without machine-driven saws to ensure perfect flatness, and without the means to precisely lift and adjust such heavy blocks? The sheer scale of this task, combined with the microscopic tolerances achieved, forces us to question the conventional narrative of copper tools and simple ramps. It suggests a command of geometry, a mastery of stone cutting, and a logistical capacity far beyond what we attribute to a civilization supposedly limited by primitive technology. What kind of tools could achieve such mirror-like finishes and such perfect angles on limestone, a material hard enough to resist simple abrasion, but soft enough to be damaged by imprecise handling? Then there are the inner sanctums of Egypt, the sites that reveal an even more unsettling level of precision, one that borders on the truly inexplicable. Deep within the Serapeum at Saqqara, or scattered across other ancient sites like Abydos and the Giza Plateau, lie massive granite and basalt sarcophagi and boxes. These objects, often weighing 70 to 100 tons, are carved from some of the hardest stones on Earth. Their exterior surfaces are polished to an incredible luster, but it is their interiors that defy explanation. The inside corners are perfectly square, sharp as if cut by a modern milling machine, rather than rounded as they would be with ancient hand tools. The interior walls are perfectly flat and parallel to each other, with tolerances measured in fractions of a millimeter, far exceeding anything achievable by chisels and mallets. Some of these boxes feature lids weighing 20 to 30 tons, sealed with such exactitude that they create a vacuum seal when lifted. The sheer hardness of the material, combined with this impossible precision, indicates an advanced cutting technology we have yet to discover. What kind of drills could create perfectly smooth, deep holes in granite with no visible start or end point for the drill bit? What kind of saw could cut through tons of solid basalt, leaving behind tool marks that resemble modern industrial cutting tools, yet without any corresponding archaeological evidence for such machines? The meticulous work seen on these granite masterpieces points not just to skill, but to a different order of technology entirely, a technology capable of manipulating stone with a degree of accuracy that still challenges our own industrial capabilities. It speaks of a lost knowledge in metallurgy, in power generation, and in the very physics of working with intractable materials. The Aswan quarries, where much of this granite originated, show evidence of rough quarrying, but none of the finishing tools or sophisticated machinery that would have been necessary to achieve the final, impossible precision found in the finished artifacts. It is a disconnect so vast it begs for an entirely new explanation. This impossible precision and colossal scale bring us to perhaps the most fundamental challenge presented by these ancient megastructures, the logistical nightmare of transporting and placing such massive blocks without known advanced machinery. From Stonehenge's bluestones, brought over hundreds of miles, to the megaliths of Sacsayhuaman in Peru, where multi-ton stones are perfectly fitted into complex interlocking walls high in the Andes, the same question echoes: how? We propose theories involving rollers, sledges, and vast numbers of human laborers. Yet these explanations often fail to account for the sheer physical constraints. How do you move a 1,000-ton block on wooden rollers without them crushing under the immense weight? How do you maintain control of such a mass on an incline without it careening downhill? And once at the site, how do you lift it dozens of feet into the air and position it with millimeter accuracy using only ropes and ramps? The archaeological record offers scant evidence of the required scale of such operations. There are no vast, ancient road networks specifically designed for these ultra-heavy transports, no remnants of colossal cranes or complex leverage systems that could manage these weights. The simple methods proposed often fall apart under rigorous engineering analysis, either requiring impossible numbers of people, an unrealistic amount of time, or violating fundamental laws of physics as we understand them. It's a paradox of immense effort seemingly achieved with inadequate means. The prevailing narrative leaves us with a significant gap, a chasm between the capabilities we attribute to these cultures and the physical evidence they left behind. It suggests that perhaps our understanding of their technology is fundamentally incomplete, missing a critical component that allowed them to achieve what we still consider Herculean tasks. The sheer audacity of these endeavors, undertaken without the wheel in some cases, without the aid of beasts of burden of sufficient strength in others, suggests a reliance on principles or power sources that remain entirely outside our current historical documentation, and the mysteries are not limited to the careful shaping and precise placement of cold stone. Across the ancient landscapes of Scotland, particularly in its northern reaches, lies another form of stone engineering that hints at an entirely different, perhaps even more startling, lost technology: the enigmatic vitrified forts. These are hilltop fortifications where the stone walls, instead of being simply stacked or mortared, have been subjected to such intense heat that the rock has melted and fused together, forming a glassy, slag-like material that binds the structure into a single, incredibly strong mass. Achieving vitrification requires temperatures of 1,000 to 1,200 degrees Celsius, sustained for prolonged periods, akin to modern industrial furnaces. This is not simply a matter of setting a few bonfires. It requires a controlled, high-temperature environment that melts quartz-rich stones. Yet these forts date back to the Iron Age, a period where such pyrotechnical mastery is entirely unexpected. How did Iron Age peoples, supposedly limited to basic kilns and hearths, generate and control such extreme and sustained heat over such vast areas? There is no evidence of the massive quantities of fuel required for such an operation, nor the advanced refractory materials needed to contain and direct the heat. Were these structures deliberately crafted in this way for defensive purposes, making them virtually impregnable, or was the vitrification an unintended consequence of some other process, perhaps ritualistic or industrial, that we do not comprehend? The very existence of these vitrified forts shatters our assumptions about the metallurgical and pyrotechnological capabilities of these ancient cultures. It suggests a profound understanding of heat, material science, and possibly even chemistry that appears to be entirely out of place for their documented era. It is as if they possessed the secrets of a foundry on a monumental scale long before such knowledge should have existed. The precise reason for such intense heating remains a point of contention. Some suggest accidental fires, but the widespread and consistent vitrification across multiple sites points to a deliberate, if now forgotten, process. These are not isolated anomalies. They are recurring patterns across the ancient world. From the perfectly shaped multi-ton stones of the Osirion at Abydos, cut from granite with incredible flatness, to the unknown methods behind the massive, interlocking walls of ancient Peru, the evidence points to a technological sophistication in stonework that transcends the known historical record. The sheer weight of these objects, the precision with which they are cut, the baffling logistical challenges of their placement, and the unexplained high-temperature methods used to transform them all converge on a single, inescapable conclusion. Our ancestors possessed a mastery over stone and engineering that far exceeds the tools and knowledge we currently attribute to them. What force was at play? What lost techniques allowed them to manipulate materials in ways that still elude us today? These questions are not mere academic curiosities. They are direct challenges to our linear understanding of human progress, suggesting that the past holds secrets of a forgotten ingenuity waiting to be rediscovered. And as we peel back these layers of stone, the possibility emerges that the marvels of ancient engineering were not just about moving rocks, but about harnessing powers and understanding materials in ways that echo far beyond the simple. This leads us to the next profound question. If stone itself reveals such an advanced understanding, what other materials and mechanisms equally inexplicable lie hidden in the ancient record? The implications are unsettling, pushing the boundaries of what we thought possible for the earliest civilizations. What other enigmas of mechanism and material science might reveal themselves, further cementing the case for technologies beyond our grasp, technologies that compel us to rewrite the story of humanity itself? The colossal stones of Baalbek and the precision of Puma Punku force us to rethink the brute force often associated with ancient builders. We have seen how entire landscapes were reshaped and materials manipulated with an accuracy that defies explanation. Yet, the past holds mysteries that extend beyond the mere carving and placement of stone. What if our ancestors were not just masters of monumental construction, but also possessed an understanding of mechanics, chemistry, and metallurgy that we are only now beginning to grasp? What if the echoes of their ingenuity resonate not only in grand structures, but in intricate devices and seemingly impossible materials? This is where the story shifts from the weight of stone to the whisper of forgotten machines, from raw elemental power to the subtle alchemy of advanced knowledge. Deep beneath the waves off the coast of a Greek island lay a discovery so profoundly anachronistic it would redefine our understanding of ancient technology. In 1901, sponge divers stumbled upon a shipwreck, yielding treasures that spoke of a Hellenistic past. But among the bronze statues and pottery lay something altogether different. A corroded mass of metal encrusted with marine growth that would come to be known as the Antikythera mechanism. It was a device unlike any other known from antiquity. For decades, its true purpose remained shrouded in mystery, a jumble of gears and dials hinting at something far more complex than any known ancient instrument. Imagine, if you will, the astonishment of scientists who, through painstaking X-ray tomography and advanced imaging, began to peel back the layers of time. They found a clockwork mechanism of astonishing sophistication, a differential gearing system, intricate bronze cogs and precise scales, all designed to track celestial movements. This was no simple sundial. The Antikythera mechanism was an analog computer, capable of predicting solar and lunar eclipses, tracking the irregular orbit of the moon, and even calculating the dates of ancient Olympic Games. It demonstrated a command of astronomy and mechanical engineering thought impossible for its era. Dating back to roughly 100 BCE, its complexity rivals that of 14th century European clocks, a full aimed at 400 years later. It had 30 distinct gears, each tooth cut with astonishing uniformity, interconnected in a labyrinthine dance to mirror the cosmos. The implications are profound. If such a device existed, it suggests an entire tradition of mechanical knowledge, a lineage of engineers and astronomers capable of crafting such wonders. How many other such mechanisms have been lost to the sands of time or the depths of the sea? The Antikythera mechanism is not merely a curiosity. It is a startling artifact that forces us to question the linear progression of technological development, suggesting a peak of ancient ingenuity that we have only begun to rediscover. It challenges the very notion that advanced mechanics are a modern invention, hinting at a past far more sophisticated than our textbooks often allow. Building on the concept of materials manipulated with unexpected mastery, we journey to another enigma, the Delhi Iron Pillar in India. Standing over 7 meters tall and weighing more than 6 tons, this pillar of solid iron has defied corrosion for over 1,600 years, exposed to the elements of a bustling city. For centuries, its remarkable resistance to rust baffled metallurgists. Ordinary iron left exposed to the humid Indian climate would corrode rapidly, turning to a reddish-brown decay. Yet, the Delhi Iron Pillar stands, largely unblemished, a silent monument to a lost art. How could ancient smiths achieve such a feat? Modern analysis has revealed its secrets, but not without deepening the mystery of its ancient construction. The pillar is composed of 99.7% pure wrought iron, far purer than what could be produced with ancient smelting techniques. But Its enduring quality comes from a thin, uniform layer of miserwhite, a compound of iron, oxygen, and hydrogen that forms on its surface. This protective layer acts as a barrier, preventing rust from spreading. The creation of this miserwhite layer requires specific metallurgical conditions, including high phosphorus content in the iron and a precise forging process at elevated temperatures. It wasn't a random accident, but a deliberate, sophisticated understanding of metal properties. The iron was repeatedly heated and hammered by hand, a laborious and precise method. The ancient craftsmen who forged this pillar understood the subtle chemistry of iron in ways we have only recently elucidated. They achieved a level of control over their materials that was extraordinary for their time, a mastery that speaks not of primitive skill, but of an advanced, perhaps even scientific, knowledge of metallurgy that has since been lost or forgotten. The Delhi Iron Pillar is not just an impressive piece of metalwork. It is a testament to an ancient understanding of materials science, a secret held by forgotten smiths who knew how to make iron impervious to the relentless march of time. It stands as a physical question mark, asking how such advanced metallurgical knowledge could simply vanish from human history. This pattern of advanced material knowledge appears again, in a different continent, with an even more perplexing material, platinum. In the pre-Columbian cultures of South America, specifically among the Tolita and La Tolita Tumaco people of what is now Ecuador, archaeological finds reveal intricate objects crafted from platinum and its alloys. This is astounding because platinum, with its extremely high melting point of 1768 degrees Celsius, is notoriously difficult to work. It requires temperatures far beyond those achievable with traditional ancient furnaces. For centuries, it was believed that Europeans were the first to successfully work platinum, beginning in the 18th century. Yet, here was evidence of sophisticated platinum metallurgy existing thousands of years earlier. How did these ancient cultures achieve this? They couldn't melt platinum directly. Instead, it is believed they mastered a process called sintering, a form of powder metallurgy. They would mix tiny grains of platinum with gold dust, which has a much lower melting point. By repeatedly heating and hammering this mixture, the gold would melt and bond with the platinum, creating a workable alloy. This process required immense skill, precise temperature control, and an intimate understanding of the properties of these metals. It was a technique that allowed them to essentially forge platinum into desired shapes, creating small ornaments, rings, and decorative objects. This wasn't merely decorative work, it was a testament to an advanced knowledge of material science and pyrotechnics. They were in essence performing a form of controlled fusion, binding different metals at an atomic level to create new properties. The pre-Columbian platinum artifacts are not just beautiful, they represent a technological leap that confounds our conventional timelines. They suggest that indigenous cultures, often dismissed as primitive, possessed a level of scientific and engineering acumen that allowed them to manipulate materials in ways that remained unachieved by other advanced civilizations for millennia. It is a striking example of ancient innovation, developed independently, that challenges our Eurocentric view of technological progress and highlights the deep, often overlooked, complexity of humanity's past. The mastery of materials extends beyond metals, touching upon the very fabric of construction. When we consider the enduring strength of ancient structures, we often look to the precise stone fitting of the megalithic builders. But for the Romans, their legacy also lies in a material often considered humble: concrete. For centuries, Roman concrete structures, from the Pantheon to ancient harbours, have stood resilient against the ravages of time and even seismic activity. Modern concrete, by comparison, often degrades within decades, requiring extensive maintenance and repair. What was the secret of Roman concrete? Scientists have only recently begun to unravel its lost chemical knowledge. Roman concrete, or opus caementitium, was made from a mixture of volcanic ash, lime, seawater, and volcanic rock. The key ingredient, however, was thought to be volcanic ash, particularly from the region of Pozzuoli, giving rise to the term pozzolanic concrete. But new research points to something even more subtle and ingenious: the presence of small white chunks of lime previously dismissed as mere mixing errors. These are now understood to be lime clasts. When Roman concrete cracks, seawater or rainwater interacts with these lime clasts, triggering a chemical reaction that creates calcium carbonate crystals. These crystals then fill the cracks, effectively self-healing the material. It's a bio-inspired process of incredible sophistication, giving Roman concrete its unparalleled longevity. This wasn't a happy accident. It was a deep understanding of material chemistry, allowing for reactive ingredients to create a dynamic, enduring structure. Imagine the implications: a building material that gets stronger and heals itself over time, a concept modern engineers are only now striving to replicate. This chemical mastery also appears in other exquisite artifacts, such as the Lycurgus cup, a 4th century Roman glass cage cup. Under reflected light, the cup appears green, but when light is passed through it, the cup glows a vivid ruby red. This astonishing dichroic property is due to nanoparticles of gold and silver suspended in the glass, each only about 50 to 100 nanometers in diameter. The Romans were, without knowing the term, working with nanotechnology. They discovered how to manipulate metal particles at a scale almost invisible to the naked eye, embedding them within glass to achieve unique optical effects. This was not a simple pigment. It was a complex colloidal suspension, a testament to an experimental mastery of material science that seems utterly out of place for its time. The Lycurgus cup is a dazzling example of ancient chemical artistry, suggesting a level of empirical knowledge that bordered on the scientific manipulation of matter at its smallest scales. Both Roman concrete and the Lycurgus cup speak to a profound, lost understanding of chemistry and material properties, secrets that challenge our assumptions about the limitations of ancient technology. And what of the very spark of electricity? The notion of ancient cultures harnessing electrical power seems utterly fantastical. Yet one artifact pushes the boundaries of this imagination: the Baghdad Battery. Discovered in 1936 near Baghdad, Iraq, this intriguing object consists of a clay jar approximately 14 centimeters tall, containing a copper cylinder which encases an iron rod. The entire assembly is sealed with asphalt. While its original purpose remains debated, many researchers believe it functioned as an early form of electrochemical cell, a battery. When filled with an electrolyte such as grape juice, vinegar, or even asphalt, the copper and iron components create a voltage, generating a small electric current. Its age is estimated to be around 250 BCE to 250 CE, placing it firmly in antiquity. The existence of such a device raises profound questions. If it was indeed a battery, what was its application? Mainstream archaeological explanations suggest it might have been used for electroplating, applying a thin layer of gold or silver onto other metals, a technique known as gilding. This would explain the pristine state of some ancient artifacts, whose gold plating is too uniform to have been achieved by simple fire gilding. Others speculate it might have been used for medicinal purposes, perhaps for pain relief through electrotherapy, or even in religious rituals to generate a shock effect. The true mystery is not merely how it worked, but why it was made. It implies a theoretical understanding of electrochemistry, however rudimentary, long before the likes of Volta and Galvani discovered electricity in the modern era. The Baghdad Battery is not an isolated piece of evidence. It joins a growing list of ancient technologies that suggest an experimental prowess, a knack for practical science that we often attribute only to the modern age. It hints at a world where fundamental scientific principles might have been discovered, applied, and then forgotten, their knowledge fading into the annals of a lost history. From the complex gears of Antikythera, predicting cosmic movements, to the enduring resilience of the Delhi Iron Pillar, defying rust for millennia, from the sophisticated platinum working of pre-Columbian cultures to the self-healing concrete and nanoscale artistry of the Romans, and finally, to the subtle whisper of electricity from the Baghdad battery. These artifacts collectively paint a picture of a past far more technologically adept than we commonly conceive. They are not merely anomalies, they are tangible proof of sophisticated mechanical, metallurgical, and chemical knowledge that, for reasons we cannot yet explain, simply vanished. These enigmatic objects challenge our neat timelines of progress, forcing us to consider that history's blueprint might be far more fragmented, far more complex, and far more awe-inspiring than we currently believe. What if these were not isolated sparks of genius, but remnants of a larger, forgotten understanding? And if these were their machines and materials, what does that tell us about their science, their astronomy, and their profound grasp of the world around them? The deeper we dig, the more we realize that the ancients were not simply primitive, they were different. And the echoes of their knowledge might still be waiting to be heard. Our exploration of the impossible artifacts and monumental feats of engineering, which refuse to fit neatly into established historical timelines, deepens when we turn from tangible objects to the realm of abstract knowledge. It is one thing to marvel at structures carved with laser-like precision or materials forged with advanced chemistry. It is another entirely to confront evidence of sophisticated scientific and astronomical understanding, complex medical expertise, and an astonishing grasp of acoustic principles, all appearing in eras we label as primitive. These are not merely anomalies of craft, they are echoes of an advanced intellect, manifesting in a past that conventional history struggles to explain. Consider the vast, silent landscapes of ancient Egypt, not along the Nile but far to the southwest, in what is now the desolate Sahara. Here, in a place known as Nabta Playa, lies a megalithic calendar circle that predates Stonehenge by thousands of years. Erected by nomadic pastoralists around 7,500 years ago, this site consists of carefully placed stones, some weighing several tons, arranged in a circular pattern. Its primary alignment points precisely to the summer solstice, indicating a clear understanding of Earth's orbital mechanics and the seasonal cycles. But the complexity goes deeper. Other stones within the circle appear to align with specific stars, such as Sirius, at different points in precessional time. Knowledge that should have been utterly impossible for a culture with no known writing system, no telescopes and no fixed settlements that could support generations of dedicated astronomical observation. How did these early people, moving with their herds across a changing landscape, acquire such precise celestial data? How did they manage the immense logistical challenge of quarrying, moving, and positioning these heavy stones to mark phenomena that repeat only once a year or once in millennia for stellar alignments? The sophistication embedded in Nabta Playa implies a depth of knowledge that defies the accepted narrative of gradual human development, suggesting instead a sudden grasp of astronomical principles or an inherited understanding from an even more distant past. Further north, in the plains of Salisbury, England, another colossal stone observatory commands our attention, Stonehenge. Built over many centuries, with its earliest phases dating back nearly 5,000 years, this iconic monument is a testament to extraordinary engineering, yet its astronomical alignments are equally profound. The most famous is its precise orientation towards the summer solstice sunrise and the winter solstice sunset. But detailed archaeological and archaeoastronomical studies reveal a far more intricate purpose. The arrangement of the sarsen and bluestones, along with the 56 Aubrey holes, suggests a sophisticated calendrical and observational tool, capable of tracking not only the sun but also the complex cycles of the moon, including its extreme northern and southern rising and setting points. Such lunar observations require centuries of patient data collection and an advanced mathematical framework to predict. The sheer scale of the undertaking involving stones transported over hundreds of miles and then meticulously erected, speaks to a highly organized society with a shared, profound understanding of the cosmos. It was not merely a ritualistic site, it was a cosmic clock, a predictive instrument of immense precision, built by people who, according to our textbooks, possessed only rudimentary tools. This raises the unsettling question: how did a Bronze Age society achieve such an advanced grasp of celestial mechanics and integrate it into a monumental construction project of this magnitude? The echoes of this inexplicable knowledge extend beyond the celestial to the very maps of our planet. One of the most perplexing artifacts in cartography is the Piri Reis map, compiled in 1513 by an Ottoman admiral. While conventional maps of its time were often crude and inaccurate, the Piri Reis map stands out with astonishing precision, depicting coastlines with a level of detail that would not be replicated for centuries. More profoundly, it shows land masses that were supposedly unknown at the time, including a southern continent, which many interpret as Antarctica. What makes this particularly baffling is the depiction of Antarctica, or what appears to be its coastline, free of ice. This suggests a mapping source that predates the last ice age, a time perhaps as far back as 10,000 to 12,000 years ago, when parts of Antarctica were indeed ice-free. If this interpretation is correct, then the map draws from knowledge accumulated at a time when human civilization, as we understand it, was barely emerging from the Stone Age. The Piri Reis map itself carries annotations stating that it was compiled from 20 older maps and charts, some dating back to the time of Alexander the Great. This implies a legacy of advanced cartographic knowledge passed down through generations, predating any known culture capable of such global exploration and precise surveying. The sheer leap from scattered coastal navigation to accurate global cartography, including areas like the interior of South America and an ice-free Antarctica, is a profound anomaly that challenges the entire timeline of human geographical discovery. Further evidence of specialized scientific understanding emerges from a domain where precision literally meant life or death: ancient medicine and surgery. The practice of trepanation, the surgical drilling or scraping of a hole in the skull, is found in various ancient cultures across the globe, from Neolithic Europe to pre-Columbian South America. What is truly astonishing is not just the existence of this dangerous procedure, but its high success rates. Thousands of trepanned skulls show clear signs of healing around the edges of the boreholes, indicating that the patient survived the operation and lived for years afterward. This success implies an astonishing level of anatomical knowledge, an understanding of hygiene to prevent infection, and masterful surgical technique, all without modern anesthetics, antiseptics, or detailed diagnostic tools. How did these practitioners, often working in what we consider primitive conditions, manage to navigate the complexities of the human skull, avoid vital blood vessels, and prevent fatal infections with such consistent success? The knowledge required was not just empirical trial and error. It suggests a systematic understanding of surgical principles that seems entirely out of place for their era. Beyond surgical prowess, the ancient world also shows signs of advanced prosthetic limbs. An artificial toe found on an Egyptian mummy and dating back almost 3,000 years is crafted with such ingenuity that it was clearly designed for function, not just appearance. Made of wood and leather, articulated and perfectly fitted, it would have allowed the wearer to walk much more comfortably. Another toe, made of cartonnage, also shows signs of wear consistent with regular use. These were not crude, impractical replacements, but sophisticated devices that demonstrate a deep concern for human comfort and an advanced understanding of biomechanics and material science, pushing the boundaries of what we assume ancient artisans could achieve. Finally, we encounter a remarkable mastery of unseen forces, acoustic engineering in ancient sites, designed to manipulate sound in ways that still captivate and confound us today. At Chichen Itza in Mexico, the Grand Pyramid of Kukulkan is an architectural marvel of the Mayan civilization, but it holds a sonic secret. If one claps a single hand at the base of the pyramid, the echo that reverberates from the steps above uncannily mimics the distinctive chirp of the quetzal bird, a creature sacred to the Maya. This is not a random acoustical fluke. It is a deliberate, mathematically precise effect. The specific angles, dimensions, and terracing of the pyramid were clearly designed to create this unique sound, demonstrating an astonishing understanding of acoustics and architectural resonance by its builders. How did they calculate and engineer such a precise sonic phenomenon without modern scientific instruments or the mathematical models we use today? Was it an intuitive genius or a forgotten science? Similarly, at Newgrange, the ancient passage tomb in Ireland, dating back over 5,000 years, is famous for its precise alignment with the winter solstice sunrise, where light penetrates its inner chamber. But studies have also revealed remarkable acoustic properties within the chamber itself. The space appears to have a resonant frequency around 70–120 Hz, a range that would amplify male voices, turning speech into a powerful, almost otherworldly hum. This acoustic resonance suggests a deliberate design, creating an immersive sensory experience that would have been deeply significant during ancient rituals. It hints at a profound understanding of how sound interacts with space and structure, elevating these sites from mere buildings to instruments of profound sensory and spiritual experience. Each of these examples, the precise celestial alignments of Nabta Playa and Stonehenge, the impossible cartographic detail of the Piri Reis map, the successful surgical techniques and sophisticated prosthetics, and the deliberate acoustic engineering of Chichen Itza and Newgrange challenges the linear, progressive view of human history. These are not isolated innovations. They are manifestations of profound knowledge appearing without a clear, traceable evolutionary path in ancient societies. They suggest a capability, a scientific literacy, that conventional history struggles to reconcile with the tools and intellectual frameworks ascribed to these eras. The question is not just what they knew, but how they knew it. How did such advanced understanding emerge, seemingly fully formed, only to vanish again, leaving us with these perplexing echoes across millennia? This persistent enigma pushes us to consider explanations that lie beyond the comfortable boundaries of our current understanding, compelling us to ask if there were unseen architects or forgotten legacies that shaped a past far more complex than we currently imagine. The profound knowledge echoed from ancient sites, the mastery of materials and mechanics, the celestial foresight embedded in stone. All these elements, as we have explored, present a formidable challenge to our conventional understanding of history. Our current archaeological and historical paradigms, built on a linear progression of human innovation, often find themselves struggling to accommodate these anomalies. For centuries, our frameworks have posited a gradual ascent of civilization, a steady march from rudimentary tools to sophisticated engineering. Each step, it is assumed, should leave a clear, traceable evolutionary path. Yet, the evidence we have encountered, the precision-cut blocks, the complex mechanisms, the metallurgical feats, often appears as a sudden leap, an inexplicable bloom of genius without visible roots in the surrounding cultural soil. This presents a fundamental tension. Traditional archaeology thrives on a methodical approach, piecing together the past through stratigraphy, radiocarbon dating, and the comparative analysis of artifacts. It seeks consistency, identifiable precursors, and a logical development of skills. But when confronted with objects like the Antikythera mechanism or the impossibly smooth surfaces of ancient Egyptian sarcophagi, the conventional narrative falters. There is no clear precedent for such intricate gearing in the archaeological record of its time, no obvious progression from simpler devices to such complex computing. The logistical challenges alone of moving and placing megalithic stones, let alone shaping them with sub-millimeter precision, seem to demand technologies that simply did not exist in the accepted timeline. The paradigm struggles to explain how a culture, seemingly limited to copper chisels and brute force, could achieve results that challenge modern engineering. It is not that these feats are denied, but rather that their means of accomplishment remain stubbornly, profoundly unexplained within the established models. And this leads us to wonder, if the accepted timeline cannot account for these achievements, then perhaps our timeline itself is incomplete, or our understanding of who accomplished them is flawed. This brings us to a compelling yet often dismissed category of theories, those positing lost advanced civilizations. The idea shifts from how ancient cultures achieved these things to who these ancient cultures truly were. For as long as humanity has recorded its stories, tales of a golden age, of a magnificent civilization swallowed by catastrophe, have persisted. Plato's account of Atlantis, often relegated to the realm of pure myth, is perhaps the most famous example. It speaks of a technologically sophisticated society possessing advanced knowledge and engineering that met its end in a single, cataclysmic day and night. While the literal existence of Atlantis as Plato described it remains unproven, the recurring motif of a sophisticated, pre-diluvian world suggests a collective memory of a time before the accepted dawn of our recorded history. But beneath the myth, there is often a grain of geological truth. The very planet we inhabit bears scars of immense change, not always aligned with our human timelines. Consider the submerged landscapes of Doggerland, the vast land bridge that once connected Britain to continental Europe, now lost beneath the North Sea, or the Bering Land Bridge, once a crucial pathway between Asia and North America. These were not mythical places, but once thriving land masses home to ancient peoples, now drowned by rising sea levels at the end of the last ice age. Such events demonstrate how entire civilizations, or at least vast settled populations, could vanish without a trace from the terrestrial record, their history erased by the inexorable march of geological time. If Doggerland, a relatively recent geological feature, can disappear, what of far older, more advanced societies that might have flourished millions of years ago, only to be wiped clean by planetary shifts, tsunamis, or even more profound cataclysms? The possibility that sophisticated human societies existed, thrived, and then vanished long before the Sumerians or Egyptians challenges our most fundamental assumptions about the age and development of human civilization. This perspective naturally leads us to a re-examination of ancient myths and epic texts. For too long, modern scholarship has often treated these stories as mere allegory, poetic metaphors for natural phenomena, or simple superstitions. Yet, what if these narratives, passed down through generations, are not merely fables, but fragmented historical accounts, distorted by time, translation, and cultural filters, but nevertheless rooted in actual events or real knowledge? Flood myths, for example, are almost universal, appearing in cultures across every continent, from Sumeria to Native American tribes. While these could simply be local observations of natural disasters, their striking similarities, often featuring a global deluge and the salvation of a select few, raise a more profound question. Do they echo a singular, planet-altering event that reshaped the world and erased the memory of what came before? Beyond deluge stories, many myths speak of sky gods or culture heroes who descended from the heavens, bringing with them advanced knowledge of agriculture, writing, metallurgy, or astronomy. The Sumerian accounts of the Anunnaki, the Egyptian narratives of the Neteru, the Mayan Popol Vuh describing beings with vast intellect, these are not isolated tales. They represent a global pattern of external intervention, a sudden infusion of knowledge that seems to bypass the conventional evolutionary path of human learning. When we combine these narratives with the physical evidence of inexplicable technology, the precise carving, the complex mechanisms, the astronomical alignments, The idea that these myths preserve echoes of forgotten eras, perhaps even interactions with more advanced beings, becomes increasingly compelling. It suggests that the dark ages of human prehistory may not have been dark at all, but simply obscured by the veil of time and catastrophic memory loss. And this brings us directly to the most controversial, yet endlessly fascinating, explanation for these anomalies, the ancient astronaut hypothesis. This theory posits that extraterrestrial beings visited Earth in the distant past, influencing human development and perhaps even directly aiding in the construction of some of the monumental and technologically advanced sites we observe today. Proponents of this idea point to several recurring themes. They highlight the sudden, inexplicable leaps in human technology or knowledge in certain ancient cultures, such as the sudden emergence of sophisticated astronomical understanding in societies without apparent prior scientific progression. They also cite the global similarities in ancient art and architecture that suggest a shared, non-terrestrial influence. Even across continents, separated by vast oceans and without known contact, the arguments often rely on interpreting ancient texts and iconography. The depiction of flying chariots or celestial beings in various religious scriptures, the striking resemblance of some ancient petroglyphs to modern spacecraft or helmeted figures, and the recurring motif of powerful beings descending from the sky to bestow knowledge or even genetically modify early humans. These are all put forward as evidence. The precise stonework of Puma Punku, the colossal scale of Baalbek, the perfect alignments of the Giza pyramids. If human civilization was truly primitive at these times, then an external, technologically superior influence could account for the seemingly impossible feats. This hypothesis is not without its challenges. Mainstream science largely rejects it due to the lack of direct, verifiable evidence of extraterrestrial contact. There are no alien artifacts, no undisputed spacecraft remains, and no definitive proof that ancient depictions represent anything other than human interpretation of natural phenomena or spiritual experiences. Yet the persistent questions raised by ancient technologies, the apparent missing links in our historical understanding, continue to fuel the exploration of this radical idea, forcing us to consider possibilities beyond the purely terrestrial. Furthermore, a re-evaluation of geological and climatological data itself suggests that human presence with a technological capability might extend far deeper into the past than currently accepted. Our standard timelines for human civilization are largely based on archaeological finds in accessible, stable geological contexts, but the Earth's surface is constantly reshaped. Vast stretches of land have been submerged by sea level rise. Others buried under layers of sediment from floods, volcanic eruptions, or glacial movements. If advanced human civilizations existed during interglacial periods, or at times when continental shelves were exposed, their cities and technologies might now lie deep underwater or beneath miles of ice and rock. The evidence for such an older presence is subtle but intriguing. Anomalous archaeological finds, often dismissed as out-of-place artifacts, such as the Klerksdorp spheres or the Koso artifact, sometimes hint at manufacturing or design far beyond their conventionally dated geological layers. Climatological shifts, such as abrupt periods of global warming or cooling or massive flood events, could have systematically erased the evidence of any widespread, advanced human presence that existed before the last glacial maximum. Our current understanding of ancient human migration and technological development often assumes a consistent, slow progression. But if humanity, or a predecessor species, achieved technological sophistication hundreds of thousands or even millions of years ago before a planetary upheaval, the traces would be immensely difficult to find. The very processes that build continents and carve landscapes also destroy or bury the delicate archaeological record. It forces us to ask, are we searching in the right places, or are the most compelling answers hidden beneath layers of earth that our current methodologies cannot yet penetrate? waiting to be rediscovered by a deeper geological archaeology. Ultimately, the stringent demands of the scientific method often clash with the unique and isolated nature of these ancient mysteries. Science, by its very definition, relies on repeatable, verifiable proof. Experiments must be replicable, observations confirmable by independent parties, and theories supported by a robust body of empirical data. The evidence for these ancient anomalies, however, often comes in isolated fragments. A single, inexplicable artifact, a unique architectural feat, a curious inscription without context. These are not phenomena that can be put into a laboratory or systematically replicated to demonstrate their construction. How does one replicate the precise cutting of Puma Punku's stone, or verify the intent behind the Giza casing stones when the original builders and their methods are entirely unknown? The problem is compounded by the immense spans of time involved. Erosion, tectonic activity, and the very human act of repurposing or destroying older structures have ensured that much of the ancient record is lost. What remains are often the most durable materials: stone, metal. But even these are weathered, obscured, or buried. To prove that a feature could not have been made by known ancient methods is an argument from ignorance, not positive proof of an advanced technology. Conversely, to assert advanced technology without undeniable physical evidence of its application, such as the machines themselves or detailed instructions, runs counter to scientific principles. This tension creates a fundamental divide: the compelling nature of the mystery versus the rigorous requirements of scientific validation. It is a dance between open possibility and cautious empiricism, leaving us with a collection of profound questions that, for now, defy a definitive, universally accepted answer. Yet, the very act of asking these questions, of pushing against the boundaries of our known history, is perhaps the most human endeavor of all. If the enigmas we have unearthed across time and continents are not simply aberrations, not mere misinterpretations of natural phenomena or the tricks of light and shadow, but actual deliberate expressions of advanced knowledge and sophisticated technology, then the very foundations of our understanding begin to shift with tectonic force. The implications stretch far beyond isolated wonders. They profoundly reshape the entire narrative of human history, demanding a complete and often unsettling re-evaluation of our past, our present, and our ultimate potential as a species. For if ancient cultures possessed technologies and insights that we struggle to replicate today, if they achieved feats of precision engineering and material science that defy our conventional timelines and known capabilities, then the story of progress is not the linear ascent we have long believed it to be. Instead, it becomes something far more intricate, a tapestry woven with enigmatic threads of forgotten innovation, lost understanding, and perhaps even unacknowledged grandeur. This new perspective compels us to look at the silent stones and mysterious artifacts not just as relics, but as profound questions etched into the very fabric of our world. Our ingrained concept of human advancement, often depicted as a steady upward climb from rudimentary tools to ever more sophisticated machines, finds itself challenged at its very core. We meticulously chart a clear, almost inevitable trajectory, the slow, painstaking development from the first chipped stones of our ancestors to the mastery of agriculture, from the Bronze Age to the Iron Age, each era building incrementally logically upon the last in a seemingly unbroken chain. But what if that trajectory is not a smooth curve, but fragmented, interrupted, or even punctuated by moments of unforeseen acceleration and precipitous decline? What if there were brilliant peaks of technological prowess in epochs we deem primitive, moments where understanding flared brightly before dimming into obscurity, leaving only a few baffling, inexplicable clues for us to ponder? This profound possibility challenges our very definition of intelligence itself, asking us to consider whether it follows a single, predictable evolutionary path or if it blossoms in unexpected eras, driven by forces, environmental needs, or even inspirations we do not yet fully comprehend. The idea that profound, complex knowledge could emerge, flourish, and then utterly disappear without leaving a clear, traceable legacy for future generations to build upon is not just unsettling. It is a stark confrontation with the fragility of even the greatest human achievements. It suggests a deep vulnerability in the relentless march of progress, a sobering reminder that ingenuity, no matter how brilliant or far-reaching, can be lost as easily as it is painstakingly gained, leaving behind only the ghost-like echoes of its former glory. This line of inquiry leads us directly into a more provocative and deeply speculative thought, the unsettling possibility of recurring cycles of civilization on this planet. What if the story of advanced human capability is not a singular, unique event culminating in our present era, but rather a pattern repeated across vast stretches of millennia? Imagine the rise and fall of multiple great societies, perhaps achieving levels of technical sophistication that, in their context, rival or even surpass aspects of our own. What if these societies were not destined for perpetual growth, but were instead swallowed by immense geological upheaval, catastrophic climate shifts, or simply the slow, relentless grind of time, erosion, and eventual forgetfulness? Their achievements, the inexplicable precision of their stonework, the out-of-place artifacts that refuse categorization, the echoes of scientific insight we've examined throughout this journey, could then be seen not merely as individual anomalies in a primitive past, but as faint, enduring whispers from forgotten apexes of human ingenuity. These are no longer just isolated mysteries to be solved. They become fragments of a much grander, cyclical drama, where knowledge is gained, then lost, then painstakingly rediscovered, perhaps imperfectly, by a new generation on the same ancient planet. The Earth itself, in this profound view, transforms from a simple stage for a single human history into a vast, layered repository of multiple human stories, each etched atop the other, leaving only occasional, baffling clues for us to decipher from beneath the dust of ages. Such a perspective demands a profound humility from us, the current inheritors of what we currently perceive as the pinnacle of human achievement and understanding. It calls for an acknowledgement that our human past is potentially far richer, far more complex, and vastly less understood than our conventional histories have allowed us to believe. The narratives passed down through textbooks and mainstream archaeology, while meticulously constructed from available evidence, may be incomplete, missing entire, monumental chapters of ingenuity, discovery, and perhaps even catastrophic loss. We are asked to consider that the primitive cultures we often categorize might have been, in a deeper sense, the direct descendants of something far more advanced, carrying forward fragments of inherited knowledge, or perhaps even remnants of a once global technological foundation, now only dimly remembered in myth, legend, and the occasional impossible artifact. This isn't about discrediting current scholarship, but about broadening its scope, inviting us to look beyond established paradigms and embrace a past that might be more mysterious, more awe-inspiring, and ultimately more truthful than we currently permit ourselves to believe. It is a humbling invitation to redraw the boundaries of what we thought was possible for our species, urging us to look with fresh eyes upon the silent testaments of antiquity. These ancient mysteries, therefore, do more than just challenge our history books. They fundamentally broaden our perspective on the very limits of human potential and the surprising resilience of knowledge. If beings with anatomies like ours, living on this very planet in eras long forgotten, could achieve feats of engineering, metallurgy, and scientific understanding that confound us today, what does that truly say about the inherent capabilities of humanity across all time? It pushes us to question the very origins of knowledge itself. Did these profound insights emerge from singular geniuses born impossibly ahead of their time, or were they the product of a sustained cultural development that simply followed a different, perhaps more efficient, or even ecologically integrated path than our own? This expanded view of our planetary past also subtly weaves our individual story into a potentially vast, incomprehensible cosmic narrative. If intelligence and complex societies can rise and fall on a single world multiple times, if the conditions for ingenuity are recurring, it suggests a robustness to the phenomenon of civilization itself, a tendency for conscious awareness to emerge and build. It makes us wonder about the universal forces that govern the emergence of capable beings throughout the universe, and whether our own planet is merely one node in a much larger, intergenerational story of mind and matter unfolding across the cosmos. It implies that perhaps the universe has seen such cycles play out countless times before, with our Earth merely serving as another stage for a timeless, repeating drama of innovation, legacy, and eventual decline, only to be rekindled once more. And this brings us to the ultimate, most profound question, one that reverberates through the very core of our understanding of who we are, and where our story truly begins. What if we, in this current age of unparalleled scientific and technological advancement, are not the first apex of human ingenuity, but merely a continuation of a story far older, deeper, and more technologically capable than we currently dare to imagine? What if the echoes of lost civilizations, the impossible precision we've seen in ancient stones, the out-of-place artifacts that defy conventional explanation, are not just random curiosities, but rather deliberate guideposts or perhaps even coded messages left behind by those who came before us? This is not to diminish our own remarkable achievements, the soaring towers of our cities, the intricate networks of our digital world, or the boundless reach of our scientific instruments. Instead, it seeks to place them within a grander, more enduring continuum of human endeavor. It suggests that our current knowledge, our accumulated science, and our soaring ambition to explore and build might not be a novel invention, a unique starting point, but rather a reawakening, a gradual rediscovery of principles and capabilities that once graced this planet in forgotten epochs. The idea proposes that humanity's journey is not a singular, unprecedented beginning, but a profound reinterpretation, a rebuilding on foundations laid by ancestors whose names are lost to time, whose cities are swallowed by the earth, and whose technologies now lie dormant beneath the dust, awaiting a new generation to unearth their long-hidden secrets. It implies that the wellspring of human potential is far from exhausted, and perhaps far from unique to our specific historical moment, connecting us to a legacy that transcends millennia and challenges the very concept of our isolated greatness. The deeper we dig into the past, the more we may find that our future is not solely our own creation, but a continuation of a wisdom woven into the silent stones.